Okay, so we're still on 6.4 Law of Sines, and this is part two of our lesson here. We have the word problem, and the word problem basically states we have a sun, and there's my sun, and a telephone pole that is tilted at approximately a 9-degree angle. So basically what we have here is we're filming a right triangle. Here's the sun, and it says the angle of elevation is 64 degrees. So angle of elevation is what goes up. That's why this is a 64-degree angle. I know straight up and down would be 90 degrees, but it says that we have a telephone pole that would be straight, but it's tilted 9 degrees. So because it's tilted 9 degrees, that is 9 degrees. So I can figure out what this angle is there now because I can do 90 minus 9 to get 81 degrees. So that's 81 degrees. And it says that the sun casts a shadow on the ground. That's 21 feet long, so that's why I know that that's 21 feet long. Just like before, I can also find out what that missing angle is, because if this whole thing is 180, I can take 180 minus 64 minus 81 to get that that is a 35-degree angle up top. So all I need to do is approximate the length of the pole is basically what we're trying to do here. So I need to find x. So this is what I know. That's 64, that's 81, that's 35, and that's 21. I want to find x. So I need these two, and I need something that has both a side and an angle. So that means we're going to use these two and these two in order to find my answer. So that side doesn't really matter for this problem. So I have my angles and my side measures. So when we do this, here's what we got. Sine of 35 over 21, because that has both of them, equals sine of 81 over b, which we don't know, which equals sine of 64 over x. And since I want x, I'm going to cross multiply the far two. So sine of 35 times x equals 21 times sine of 64. I divide both sides by sine of 35, and I get x is about 32.9 feet high, which means that the telephone pole is about 32.9 feet high. A point P on level ground is 3 kilometers due north of a point Q. A runner proceeds in the direction north 25 degrees east. From Q to a point R, and then from R to P in the direction south 7 degrees west. Approximate the distance run. So there's the starting point. So this is what I like to do. There's P. This is where we start. And a point P on level ground to a point Q. So what it says is a point P right here on level ground is 3 kilometers due north of Q. So, alright, so here's the point Q. That's 3 north. A runner proceeds in a direction north 25 degrees to the east. So that's why we did it this way, because this is north and that would be east. So it opens up this way. That's why it's north 25 degrees east. From Q to R, and from R to P, they went south 70 degrees west. So south 70 degrees west. Okay, but keep in mind, south 70 degrees, okay, is what we need to keep in mind. Approximate the by alternate interior angles to figure out all the stuff. I know that this whole angle is 70 degrees. It doesn't mean that inner part is 70 degrees. It means the whole angle from here to here is 70 degrees. But because these lines are parallel lines to each other, if this angle is 25, then this angle in here is 25 degrees because of alternate interior angles. So 70 minus 25 will tell me what that little angle is in there. So it's actually a 45-degree angle. So we have our triangle. So I can find out what that missing angle is in there, because I know that 25 and 45 is 70. So that angle would be 180 minus 45 minus 25, which is 110. So I need to find the distance run. So in order to do that, basically they want from Q to R, then add that to the distance from R to P is basically what we want. So here is our triangle that we have. Alright, let me just have our triangle all out for us. Okay, so I need to figure out what those are. So it's sine of 25 over Q, which I don't know, sine of 110 over P, which I don't know, sine of 45 over 3. Because this has two items in, that's the one that I need to use. So I need to find out what P is, I need to find out what Q is. So I can cross multiply here. So that's sine of 110 times 3 equals sine of 45 times P. So to get P all by itself, I divide both sides by sine of 45 degrees. So I get about 4. So I know that P is about 4. Then I need to cross multiply again with the far 2 because I need to find out what Q is. So that's sine of 25 times 3 equals sine of 45 times Q. So I divide both sides by sine of 45, and I get approximately 1.8 for Q. So the total distance from P and Q together would be 4 plus 1.8, which is 5.8. Alright, another one. A commercial fishing boat uses sonar equipment to detect a school of fish 2 miles east of the boat and traveling in the direction of north 51 degrees west at a rate of 8 miles per hour. So here is our boat. There's our ocean. Here are our wonderful fishies. Okay, so we know that the commercial boat detects a school of fish 2 miles east. So there we go. Then north 51 degrees west, that's that in there. If the boat goes 20 miles per hour to cut off the fish, in what angle should the boat go to intercept the fish? So we need to figure out from here to here. Well, I know this is 90 degrees, so 90 minus 51, that's 39 degrees. That's how we get that. So distance equals rate times time. And the distance the boat is 20t because we know the rate. We know that it's going 20 miles per hour, so it's 20t. So here's what we know. We know that the boat, if it goes to intersect the fish out here, is going at 20 miles per hour or 20t. We know the fish, which are right here, go at 8t because their rate was given as 8 miles per hour. And I know the distance in between them, and I know the angle there in between them. So here's what we have. We know that's 39. We know that that's 8t. We know that that's 20t. I do not know that angle that I need to find, so that's what I'm trying to solve for. So it means it's sine of theta over 8t equals sine of 39 over 20t. So when we cross multiply, so you just need to find the angle. I end up getting this, but to get sine of theta by itself, I divide by 20t on both sides. And the reason why this is okay, even though there's another letter, is the t's will end up canceling out, giving me 0.251728154. So remember, to find an angle, you need to do the inverse sine or sine of -1. So it's sine of -1 of 0.251728154. So if the boat goes at about 14.58 at that angle measure at 20 miles per hour, it should intercept the school of fish coming on the side. So in terms of vectors, though, because you want things in terms of vectors, this angle right here is 14.58. So 90 degrees, I need to find out what this angle is for vectors. So you do 90 minus 14.58, so that's 75.42. When you do vectors, you always do north or south first. So it's north 75.42 degrees east would be the correct answer. And that is the end. So if you have any questions or concerns, please let me know, and I'll talk with you all later.